In the last two videos, we took a look at solving quadratic equations, equations with x squared in it, two different ways. In the first video, we were able to use inverse operations. We used square root to kind of unsquare something in these quadratic equations. And then more recently, we saw that the zero product principle is needed when you have x squared and x in the same equation. We learned that getting x by itself, isolating x using inverse operations kind of fails us at that point. So let's take a look at what's in front of us today. The first example we're going to look at is negative x squared plus 3x equals 10 minus 8x. And in this one, the quantities are a little bit, I guess the equation is a little bit messier in general. So I could imagine two thoughts. One would be maybe I'm going to cross my fingers and hope that I can use inverse operations. And maybe the other one would be I really want to focus on zero product principle since we've seen that work. But the idea of inverse operations, as soon as you start realizing that the x's on both sides are different numbers of x's, there's a different quantity of x's, those x's are going to end up somewhere. They're going to be somewhere in the equation, and this unlike term x squared is going to be somewhere in the equation. And what I've used as a rule of thumb is if you have x and x squared in the same equation, inverse operations are not going to work. We're going to have to rely on the zero product principle, at least for now. So let's move and let's change our thinking towards that. Then this quadratic equation, we're going to use the zero product principle, which means make an equivalent equation to the one we were given with zero on one side. And then we'll have the expression on the other side. And because we're going to end up factoring this thing, it's smartest to put that into standard form. So I'm going to look at the equation and think, as I move terms from one side to the other, or as I use balanced operations to get rid of terms from one side and zero that side out, I want to try to probably get to where there's a positive x squared term, because factoring is just a little bit easier that way. And that's going to drive which side I go to. So I'm going to look and see, I will add x squared to both sides so that my negative x squared term disappears. It's not necessary that you do that. Some people are perfectly fantastic at solving or factoring expressions with negative x squareds. But early on in your factoring, I think it's a little bit safer to do this. And then since I've now decided that, I'm going to subtract 3x from both sides also. That way I can zero out the left-hand side. So on the right-hand side, I have the 10 that was there. I have the negative 8x and the negative 3x I'm going to combine, and I have this positive x squared. But what I'm going to suggest to you is that we put them in standard form as we reorder them, as we rewrite them, so that your x squared term is first, because that just kind of suits the eye. That's what it looks like when we factor or when we've been practicing factoring. So at that stage of the game, then we're going to factor the quadratic. And it was nice that there was no number in front of x squared, because we know that can be a little bit easier sometimes. We need to factor pairs of 10. And these are the ones that were a factor pair of 10 that added the negative 11. And then the zero product principle now kicks in and says, we've worked hard to get it to where it says something times something equals zero. So that means that either this quantity is zero or that quantity is zero. So we split this into two separate equations. So we've gone from a quadratic to two linear equations, and solving those equations is always much easier. So x equals 10 and x equals 1 are the two values of x that make this original equation true. And one thing I failed to mention was we knew two answers were out there because of that fundamental theorem of algebra. The highest exponent that you see in your equation is going to tell you the number of answers you're going to get. Okay, so there's our two answers. First example down. And our second one, let's see what we have here. So in the second one, I think that the organization of the terms is a little bit easier. So it kind of tempts us into a trap that I see a lot of times. Some students are excited to notice that they can factor this thing. So some students will factor that, or worse yet, some problems are presented to you where there's a factored expression on one side and a non-zero number on the other side. Don't fall into that trap. This is the zero product principle. Let's be loud and clear about that. The only way that you can say something times something equals zero is if one of those two pieces were zero. We don't have the luxury with something times something equals, in this case, 8. It could be 8 and 1, it could be 2 and 4, it could be a half and 16. There's a million of them, but zero product principle is really powerful. So that leads us to our first decision, which is going to be to subtract 8 from both sides. Why? Because we're going to zero out one of the sides. And noticing the x squared term is positive, it's going to just be a little bit more convenient if we bring everything to the left side and zero on the right. Okay. So now you may be worried that we can't factor that expression, and we've missed our boat because up here we could factor, but factor pairs of 14, 1 and 14, nah, they don't add to 5. 2 and 7, if we play our signs right, we can make a negative and a positive that would multiply to a negative 14 and add to a negative 5. So I do that. And then we're on our way. Take those two factors, set each one equal to 0, because one of them has to be 0 if their product is 0. And then our two answers would be 7 and negative 2. Okay, just one last example here. And in this one, we're going to try to apply our learning to some problem situations. And it's a bit contrived, but I wanted you to see how, we've been working all year to try to build your confidence on writing equivalent equations and trusting that if you're writing your work down carefully and systematically, that you're going to keep getting a nicer and nicer look at your equation. And then ultimately you'll say, okay, now I got this and I can move with extreme confidence. So we'll start off with a problem situation. It's going to look real messy to begin with, and then we're going to use that principle. Let's see. The combined area of the square and the rectangle and the figure is 221 squared centimeters. Find the value of x. So I do see a square and I do see a rectangle. When they say combined area, I'm thinking the area of the square plus the area of the rectangle must be 221. Okay, so there it is. Area of square and area of rectangle, that's going to equal 221. And because we have to try to express x, we have to come up with a value of x, it's really important that we don't leave it as length times width. It's a great place to start, length of the rectangle, width of the rectangle, same thing with the square, but we have to ultimately bring those expressions in. So my length and width of the square are both x. Probably could have used side squared if we wanted to. And then there's the area of the rectangle. And so now our real world work is done for a little while. This is now the entire thing that we need to work through. So take a breather and think, this is an equation. Right now, I don't see an x squared in it. I only see x's. But I kind of see the makings of an x squared in a couple of places. So we have to recognize this is a quadratic equation. And until we know for sure, we probably have to assume that it's going to be one that has x squared and x in it. So we're probably going to move towards the zero product principle, but let's see how it plays out. Left-hand side's a mess. We have to simplify that. And I see two terms. I see this term here separated by a plus sign, and then these guys. So I will FOIL here, and I will just make that an x squared. And then those four terms should never remain four terms. When we FOILed, we should get those down to three terms. And while I'm at it, I'll combine this like term over there. So now it's becoming really clear that the x squared and the x are both going to survive. So I will apply the zero product principle, meaning get zero on one side first, and oh boy, that thing, look at that thing with a factor. Number in front of x squared, it's always that worst case scenario, but let's start thinking about what we do when there's a number in front of x squared. First thing we look for any factoring is a GCF. And good news, there's a GCF there. And better yet, this entire factor 2 is found in both of those terms. So when you take the GCF, you actually now have the expression for factoring doesn't have a number in front of x squared, so we kind of lucked out. 108 is on the times table, it's 9 times 12, and those are 3 apart, so that's going to work out well for us. We factor it down there, and then we can set those factors equal to 0. Now notice this 2 didn't get set equal to 0. The 3 factors were 2, x plus 12, and x minus 9, and for some reason I only chose to do x plus 12 equals 0 or x minus 9 equals 0. And the reason for that is this 2 is never going to equal 0. Another thing we can think of is this equation was signaling us there's only 2 answers here. And those answers come from this linear equation and this linear equation. This one here is 2 equals 0. If we wanted to set that factor equal to 0, is a little tiny equation with no solutions. So nothing's coming out of that. Only answers that are coming out of this are our x is negative 12, and this our x equals 9. Now, a little while ago, I said that our real world kind of job was done for a while, because all of this here is very much not real world. It's just kind of, good procedure and good confidence in algebra. But right now, I think we better take this back to the real world. Because if we're looking at this figure and telling someone, hey, I got it, these side lengths can each be negative 12, I think people are going to be a little confused if you tell them there's a negative side length. So as it turns out, the real world context is telling us the only answer for this problem is 9. The 2 answers for the equation were correct. The only answer for the problem is 9. So apparently this side here is 10, and this is 14, and these are each 9, and that would have given us a grand total of 221. Or if you wanted to check your work, it does work out. As always, good math leads to good results. And that's the end of this video. Thanks.